clean, that is clear for all the toxic gases to leave. That is more or less a relatively 25-year modern add, because over 60% furnaces, that's a 90, a 60% furnace didn't have it, it keep running. And the only thing that would stop it would be the limit switch or the heat exchanger main limit, because it was overheating and that heat back down to the heat exchanger. So that's a good thing. Any questions? Okay.
Last one. And the other one in sixth place is a bad heat exchanger. Now, when I say bad heat exchanger, I'm talking about both the primary heat exchanger, which is behind all of this, or behind the wall of the furnace here. That's the main component of the furnace. And high efficiency furnaces, an easy way to tell if you have a high efficiency furnace is if you have PVC venting. So if you have plastic pipes coming out of your furnace instead of a steel one like mine, that means you have a high efficiency furnace. Mine is not high efficiency, it's just an 80% furnace. So it has just one heat exchanger, the primary heat exchanger. And those high efficiencies, they have two. They have the primary and the secondary, which creates water or condensation. So what is a heat exchanger and why is it so important? The heat exchanger is the main component of the furnace, and that is basically the thing that separates your house air from the combustion fumes that are going out your chimney. Usually it's a tubular looking thing, it kind of snakes back and forth.
Yes.
They do it that way so it
J-man,
stays in there longer, so it's not just going straight up and out. That way you're losing a lot of efficiency. Or sometimes it'll be split up into cells, and those cells or tubes, with time they will crack. And although they are designed to last as long as the average life of the furnace, which is about 15 years, there are circumstances that can kill them a lot faster. So for example, that dirty filter that we talked about earlier, if your furnace is constantly overheating, that will kill your heat exchanger a lot faster. Or a plugged A coil, or bad ductwork, or maybe your furnace was installed poorly to begin with, that can all decrease the lifetime of a furnace. I've condemned furnaces before that were only 6 or 8 years old. So what this would look like, a lot of times the customer will call us because the furnace is simply not working, or something's not right, or something smells outside by the exhaust fumes differently. A lot of times I'll come and I'll see that the flame rollout switches, which in my case are right here. In different furnaces, they're in different spots. But these flame rollouts are manual reset switches. They have a little button on them.
Rollout switches, it'll be on your test. Looks exactly like the limit switch, but it has a button on top so you can manually reset. And the reason you have to manually reset as a technician is because you see where they're placed outside the heat exchanger. This is a heat exchanger with a, what are these?
Igniters.
That ain't no igniter. What are these three things? We haven't covered that yet. Burners.
Burners, there's a.
And so this heat exchanger is behind this wall. And so these are rollout switches, meaning they're safety switches if flame rolls out of the internal furnace. I think we might have talked about it in the past. If the flame rolls out,
Don't put your face in the way.
and these switches were open, it doesn't take much heat. And that's what I told you when my eyelashes got burned off, right? That flame rolled out of that furnace. These are not the old standing pilot burners that the flame comes up and goes north-south. These are in-shot or upshot, and these burners are like a rocket. They come out, they can sound like that. And so for that flame to back up and come out, it must be a broken vacuum for the heat exchanger to be leaking, because the heat exchanger is like an iron. It's sealed. If it cracks or separates, the air will go through it and cause the flame to redirect.
If your flame rollout switch is tripped, that means that your burner chamber right here was getting too hot, or sometimes the flames literally roll out backwards, and you can see them just coming back out.
You see all that burn right there?
If it's getting too hot, they
You
will
see
trip.
that?
And
That
one
flame
way
been
to
rolling
tell
out.
the heat exchanger is
That's
bad
a
or
done
not
deal.
is by putting a combustion analyzer probe into the chimney, or into your exhaust pipe and seeing how much carbon monoxide is going out your chimney, it should be generally under 100 parts per million on a normally operating furnace. Generally, if you have
What's that?
So when your flame roll out, what's wrong with it?
Flame shouldn't roll out. That means you probably have a cracked heat exchanger, a restricted heat exchanger. Flame blows around the heat exchanger, not through it. So if it's blowing around it and it's convection, taking that heat, blowing it into the environment, and it's a crack in it, then that's gonna redirect the air. On older furnaces, you'll see a flame turning yellow and be that tall, when it should be blue like that, yellow tips. So, the other sign was when you saw that brown overheating on the face of the wall behind the gas valve where the heat exchanger is. If the heat exchanger gets a hold, it creates more heat. That's on the cabinet of the furnace. So when I see that, I'm saying, deal's off, man, you need a new furnace. Deal's off. I'm not touching it. I'm gonna shut the gas off. I'm gonna clip the right, red wire. Roll it back. Cause you're not gonna say I came there and do it. I'm gonna write you an invoice that says this furnace needs to be replaced. You gonna sign it. Do not run or operate this equipment. It is unsafe and dangerous and could cause harm to death. You write that on there. I have clipped the red wire so the furnace doesn't come. Sometimes I disconnect the gas line cap. And nowadays I take pictures of it. Because people have somebody, hey man, you're not trying to make me buy a furnace and come to y'all. You all happy. I'll put it back together, la 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 la. And then burn somebody's house down. And the family dying, it is a long day. You might as well be a gunslinger, cause that's the time you gonna get. You getting ready to get sentence. Don't get no lawyer, you ain't gonna need it, cause it ain't gonna help. I'll put some money on the book.
Please do.
Carbon monoxide parts per million will go through the roof. They'll be like 2,000, 3,000, 4,000. And then you wanna pull out your probe right away, otherwise it'll peg your meter. If the carbon monoxide going out the chimney is that high, then generally you are having a problem with your heat exchanger. And then if we want to visually verify if it's bad or not, sometimes you can pull the blower motor out. If you have an 80% furnace, you can pull the whole thing out, get under there and look at it from the bottom where you see the whole heat exchanger and try to find a crack or
That's what it looks like.
that way. Or you can
And so, you can buy for like $100 sea snakes. You ever heard of a sea snake?
No.
It's connected, say like to a cell phone, and it's about a 6-7 foot probe, and it has a camera on it. And you can stick that camera up there, the camera has a light on it, and you can see that. Because when you tell somebody they need a new furnace or crack heat exchanger, this day and age, you need to show them, especially something like that. And then in my invoice, all of you guys are like computer savvy enough to, that's why you do those PowerPoints in Dr. Duncan's room, that you make you like a PowerPoint of that and what you saw, and then it's at either the middle or the bottom of your invoice. You make it very clear that this is a problem that needs to be corrected only by replacing the equipment. I may not do it, and I'll tell you, you need to get someone that is licensed to replace this equipment. I'm gonna get my service call money, my analyzing money for analyzing it, and I'm gone. I'm gone. Don't mess with that. Some people, I will say this, you can replace heat exchangers. For a furnace like that, it might be $200. You gotta take the furnace apart, all the apart. Put it on, seal it, put the right, bands in it so it doesn't leak, and you can replace the heat exchanger. I don't. That's too much work. You gonna get a furnace. That's too much work. Taking all that stuff apart, putting it all back together. Man gonna lose his head back there, his head about to fall off. Way
Who, me?
back. Oh, that was you, you're here, you know.
Take out that. Those smoke for,
There he
you
is.
can also sneak in there and try to see where the cracks are. Long story short, the American Gas Association states that by code, if there is a crack or a hole in your heat exchanger, the heat exchanger or the whole furnace must be replaced. And the reason that's so important is because the heat exchanger is the thing that keeps all the combustion fumes out of your house supply air. So if that thing has a crack or a hole in it and it's producing that much carbon monoxide, and somehow that carbon monoxide leaks out into your air supply, especially at night when everybody's sleeping, it will only take minutes to kill everybody in the house, including the dog. But anyway, enough about the heat exchanger. Moving on, in 7th place, we also have a two-way tie with 11 calls each. The first one is a bad igniter. Your igniter is right here.
That's true.
In mine, it's on the
Let
right
me tell you
side.
something about these. There's a lot of these. Those are called flat surface igniters because they're flat. They have a porcelain insulator, and then this is a plug-in that plugs into the board. Sometime when you get an aftermarket, it doesn't come with this plug.
So what you supposed to do?
Huh?
What you gotta do then, in that case?
I cut it right here. I cut it here and here, strip it, and off the old one, right? And the new one will have wires this long. So it doesn't have this on the end. So I'll cut it here as close as I can so I can use that fitting, and then I'll strip this, tie it to this end of my new one, and plug it back in the board. You cannot touch this with your fingers or it won't work. Once you get that grease on there, you can't touch this carbide material. I call it, they're a little better now, but not much. I call them potato chips because if you touch it, like just trying to put it in sometimes, it's weird reaching up in there. You can tap it on that metal, it's gonna break. It breaks so easy. When they first came out, I replaced 3 of them on the same furnace, so I couldn't install it. I didn't know it was so fragile, you know? And so all of them aren't made like this. And they start making another cylinder type as well, but it's carbon, and they have some that's single, and just one side, this is double. The other thing is, when they go bad, they might just have white dots the size of rice on it. It's bad. You can stick an ohm meter in there, but it's bad, and sometimes it'll be a black, shiny, spot on it about the size of rice. It's history. Sometimes it'll just be broke, and you look up under here and see the piece down here, it's history.
What's it made out of again?
Carbide. It's the carbide type of material, like a lighter carbide, like when you strike one of the sticks to start a campfire, it's that carbide that's making that spark. That is very common. I carry 3 or 4 different types, or 2 types, 3 or 4 on my service vehicle. It's not gonna like it. To me, that's number 3. The baby keep cracking. And it don't take a long time. Furnace will be 2 years old. I look up under there, I said, geez, man, they don't make nothing no more. So I carry them so I don't have to go back. And if it's a regular customer, I will take, another one and leave it on top of the ductwork. I'm gonna charge you for it. So if I have to come back January 10th at 20 degrees, I got it already there. I keep filters up there. If you're my customer, I'm gonna keep filters up there in a garbage bag, and I'm gonna keep an igniter right there. It's already there.
Usually you'll have a plug like this, a little Molex plug that you can unplug. What that will look like is the customer says the furnace turns on, it seems to start working, but it never actually lights. So I come down to the basement, I turn the furnace switch off, turn it back on,
Never
and I
goes.
see what it does. So you'll see the inducer motor come on. After a while, generally you will hear the gas valve open and a little bit of gas will come out, but the igniter was never blowing. Most of the
That is not true. Liar. You know why it's not true? It sounds good though. because don't get good grammar mixed up with good intelligence. You know why that's not true? He said the gas valve opens, didn't he? That's a number one bad thing. Fire before gas. Does that make sense? I'm wrong. Fire before gas. If you get gas and then fire, what's gonna happen when it like, whoo? That's what's gonna happen. Fire before gas. You'll hear the gas go a little, oh no, you got a problem if that happens. Cause you should glow first. It should never do it. I have seen some that go, but it shouldn't do that if I don't have flame. Never. If that's doing that on a particular maker furnace, that is an awful design. Fire before gas. That's even the sequence of operation. That's worthy of noting. Fire before gas. Because if you hear that gas sizzling, and that igniter decides it wants to light, something getting ready to happen in it. No. It's getting ready to go poof and shoot a dragon on you. That's not true.
Sometimes that means your igniter is bad. And if you wanna check it with the meter, you can put your leads into the plug in the metal parts. One lead in here and one lead in here. If the igniter is getting 120 volts, but it's not glowing, then you know you have a bad igniter. Or you can turn the power on to your furnace, unplug your igniter, and then set your meter to resistance and put both leads into both plugs.
If you have an enlarged prostate.
Boy, what's wrong with these people? Jeez.
And if you have OL, that means the igniter is bad as well. And once you replace it, your furnace should fire right back up. And the other one in seventh place with 11 calls is a plugged A coil. So it'll be a similar scenario where the furnace is overheating and tripping on a high limit.
Why would it be plugged, did we say? What's the A coil? Some people call it the A coil. I don't take anything for granted that you know anything.
It's the
Evaporator.
That's what you.
Trade people always renaming something. That's one thing about, so if you don't know something, it's kinda hard, especially, A coil, especially if people speak another language. So they're saying, okay, that's the evaporator, then you get on the test and they say A coil, you're like, what? Are you talking about A coil is over there, or A coil as a component? See how difficult that could be? A lot of you didn't know that, did you? A coil is an evaporator coil. Why do we say it could be plugged up?
Oh, cause they didn't have filter.
No filter is worse than dirty filter. Y'all look like I forgot your break or something, did I?
No, we just,
Listening, yeah, we taking it in.
we got some.
Oh, you still got a little minute, so. Where my key?
Did I bring them back?
No.
Did I still have them?
Huh.
I do, that's why I came.
You do?
Yeah,
Alright.
old man brain fart. Short timers, all the time.
Hey, man. You gonna do that one by yourself. Locked out to a very low tire. I'm here to get that taken care of. Dang, girl, you catching hell. That's Miss Biggs. More baby. Get your tire fixed. When you're tiny here.
Okay, so,
So, ask question.
I'm just saying, yes,
No gas before fire. That is so serious of a service call. No gas before fire. Fire before gas. Fire before gas. Fire before gas.
like a lighter that doesn't work, a lighter that does work, like I'm trying to use like my grill with the grill lighter, but it's not working. I'll like do a flame with the lighter that is working and then
Light it.
light it.
I don't mention that, but it can't happen. Any kind of fire is fire. You know, It was a real cold 1 o'clock in the morning on New Year's morning, and my igniter went out on one of my furnaces. So I took one of them lighters, which is a no-no. But all I needed was some fire. And I snapped it, and when it sequenced, the gas came on and it lit. But as soon as the house read temperature, it's gonna go out and it's not gonna work. I just didn't wanna freeze. But here's one thing too about that igniter is that he started off saying flame sensor, correct? And this is one without an angle. I told you some of them are different, that was straight. And so the flame sensor senses flame, even if the sequence says click and you did get a little gas, right? But you didn't mention that. The flame sensor in less than a second says, I don't sense no heat. Gas valve closes immediately, 100% shut off, immediately. Doesn't go, wait a minute, it just shuts off. Your blinking light will say, no flame, no ignition. Flame sensor, not flame sensor, but igniter. It'll give a signal for the igniter. That's how important that part is.
Customer service wise, let's say it's freezing outside, well below freezing. You go to a house that's been out with heat, they've got a young baby or an old person or whatever, you can always light the frickin' flame yourself. Let it warm the house up, disable it, then go get your part if you don't have it.
Or if it's at night, I say turn it up to 90.
Just be careful.
I don't care how old you are or how many babies you have, go to a hotel. Because guess what? You living, you'll be alive in the morning, right? And I carry electric heaters. I say, just put this in a small bedroom and all y'all go in there. I'll come and get it tomorrow. Don't sit that electric heater on the floor. Sit it on a cookie sheet. I sit mine on a cookie sheet. When mine went out, I couldn't even sleep because I got this thing that I'm gonna be waking up, burning up on fire. So I sit it on top of a table that is metal on a cookie sheet so it's not burning down, and then I let it run, and I never sleep well that night. I'm not leaving nothing running for nobody. I don't care how many children you have, they're gonna be cold, crying, but living the next morning when I come with the fire. They're gonna be living. And then they be going, woo, it's warm now. So that's better. Don't never make decisions like that. It's always safety. Always safety.
And a coil or the evaporator coil is part of the air conditioner. And if you have an upflow furnace, generally it'll be sitting on top of your furnace, and you'll see these refrigerant pipes coming to it, along with the drain line on the bottom here. And this coil, it looks like a radiator, almost like the unit.
Now you see why they call it the A coil, don't you? Because it's shaped like an A. Some of them are H coils and they're shaped like an H. Some of them are slabs and they go straight across because it's a slab. That's the most common.
You have standing outside, your air conditioner, you know how it gets plugged up with time as it's sucking air on the sides? So same thing happens with that one. After a while, especially if you're not very good at changing your furnace filters, or if you have a filter that lets a lot through, after a while, all the dust and debris that gets past the filter will settle on the
There it
underside
is.
of that egg coil and plug it up.
There it is. That is my, you want a service call, girl? I got one for you. You can have it. You can make you about $400. You can have it. I don't want it. I don't want it. Because some people will try to take a screwdriver, pry it up and lift it. Now you still have to watch the refrigerant lines not to crimp them. I take the refrigerant out, pull the coil out, take a fan comb, which combs is made for the spaces in the evaporator. It comes with like 6 different combs. You get that one, and you can comb that out. And some people will take it outside and blow nitrogen through it. And it'll be a dust hurricane in the yard, but that's, you know, don't do it near their Mercedes. or their Silverado brand new truck. You know how you are about your cars, right? Everybody like that. Or their child is playing. They're not gonna have this in a book. Or somebody's child playing in the yard, dust all over the kid over there. Mommy, now you're gonna be angry. Because you just blew that in their kids' eyes and stuff. Now that you gonna pay for an emergency call, hope they don't call Morgan and Morgan. You have to be very mindful of what's around you doing this work. That's ugly.
Do the coils bend easily?
They can bend very easily. You have to be careful, don't stick no screwdriver in it. They have thin coils, some are made of metal like a little broom, and it'll go up in there. And it'll clean that out of there. But you can't put water on that. You get that off of there. Now that right there, it will cause your air conditioner to freeze up all the way back to the compressor. Why? Everything is about flows. How many flows?
4.
What are they?
Air, water, refrigerant,
Pressure.
That's air.
Is that air, water?
Air, water,
Electrical.
refrigerant, and electrical. Every service call is gonna affect one or two of those, guaranteed. That ain't in no book, that's Harrison.
Turn up.
I guess after so
Air,
many.
water, electrical, and refrigerant.
Refrigerant.
Those are the 4 flows that affect all service calls. One or more. And it's true to heart. And like he made a list, I made a list and said, wow, it's all about flow. It's about flow, that's the whole deal. If there's no electrical, that's electrical flow. That is airflow, which is an abundance of problems in our system, is airflow. Airflow could be a dirty filter, the worst is no filter. The rest is vents shut down. Our people, all the kids grown, I'm shutting this down. You never shut the vents off in a house. When you design them, they're made for, airflow is made for every vent to be open. People do it all the time. You're gonna go on service calls. Well, my kids are grown. I'm not paying to heat that bedroom. The system's airflow is made for flow to come out of every register. It works better like that. It works better. They don't believe in it, so that's why we get paid to make believe it. What's wrong with me to open that vent? That one back there.
I don't know.
And you're gonna take a picture of that, right?
Yeah.
Because if I can find a coil brand new like that, just like it, that's what you're gonna get. That's $1,400. I'm gonna pay $200 for the coil. I have to brace it back up, put the refrigerant back in, vacuum it down before we do that, airtight it with mastic, seal it off around the openings where the line comes with refrigeration gum.
2 hours.
Test it, test the drain, make sure we clean that little tray up under the coil, because if it has dust in it and it clogs it up going out that plastic pipe, now that's a problem. So you might be 3 hours. I might be there 4 hours, because I'm not coming back. I don't come back, so I make me enough money, I don't care if I come back. I'm not coming back.
Coming back.
I'm not coming back, man. I'm not
What
coming
about-
back. So, your reputation is this. He's kinda high, but he does great work. Isn't that a benefit? He does great work. So they call your cousins, and I'm gonna tell you now, girl, he ain't cheap, but he does great work, and he doesn't have to come back. And the number one, he's always 15 minutes early. And he cleans up, or she cleans up around herself. That little miniature vac, I clean everything up, wipe down, wipe the floor. People notice that. They film everything. Everything. You can't lie no more. They film everything. And you should like that. You should like it. You shouldn't have a problem with someone filming you, because that makes you do what? Do your job better, doesn't it? So you can say, I'm doing my job better because somebody's looking at me. And so some of the things we're talking about today, these do occur, and this one happens quite a bit, especially on rental property. Because the landlord is not taking care of the property, they just collect. They collect. And the person doesn't know. They might be a good tenant and change the filter, but when I give out of one, and I have other stuff going on in my life, I'll change it later. I'll change it later. Now it's the year and a half, I'll change it later. So it's best to have a regular maintenance plan. Most of service calls are a direct result from what? Lack of maintenance. On your car too. Don't change the oil, air filter. Get your tires rotated. Change the brakes when you first hear eek, 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 because after that, what you gonna hear? And that's rotors. Maintenance. Maintenance. There's a lot of money in our industry in maintenance. You could be a maintenance company that you run filter checks, clean condensers, clean equipment, run service checks. You could do that like most companies do in the spring. They might do $80 and do 10 a day for 3 months.
So that's
That's $800 a day.
Is that per house, is that about twice coming to that person's house?
That's per unit for me.
You go fix it.
I'm not doing 80 units and $80 and you have 5 units. People understand business. And you have to explain, $80 per unit. That's normal, $80 per unit. Because I'm gonna do a thorough check on each one. Nobody's coming to your house doing 4 units for no $80. I mean, people know what it costs to do work. And I'll say, well, can't you do it for like, charge me for 3? It's $80 per unit.
So you gonna get
You
through
know,
that?
that's our price. And I don't never say it's my price, even if you're in business, don't make it personal. I say that's our company. I might have 2 workers, that's our company's policy.
That's right.
It's not me, so you're not dealing with me, that is our company's policy. That's what it is. You're not dealing with me. I'm only me with my family, but I'm out there, I'm a company. No, you have to take it seriously, or you're never gonna make any money, and everything's gonna get personal, and you're gonna get angry going back and forth, so you just say, that's company policy.
That's right.
I'm sorry we couldn't service you. Maybe at another time. Have a great day. Have a great day. Have a great day. But this is ugly. That's why you wear glasses and gloves. I don't even wanna breathe that, cause I'm paranoid. Imagine what's in that, huh? There's some stuff in there. 2 years of breathing and stuff, and you know, bacteria and fungus and, it's all kind of stuff up in there.
That's mostly
Before you do
I have a question. So, if that's clogged like that,
Yeah,
and like say
that's-
they didn't have a
maybe that's
filter on
scary.
it, that got clogged like that.
Call you to do
and
it.
because
Huh?
Call you to
it
do
used
it.
to run
Sure,
downhill,
if I get
because
paid, I'll do it.
That
No,
would,
okay.
that's clogged.
Here's
it
the
would mess
deal.
up.
We said restrictions, 4 types. I didn't talk too much about what service problems could result in that. In the heating system, what do we say about restrictions? What happens? What happens to temperature if air can't blow through that
It
coil?
goes up, right.
Temperature rises, you're restricting it, and what's gonna happen? We said it before. What component is gonna,
Knock out.
not pressure?
The-
We said it's 3 ways, 98% is 3 ways we control systems. What? Pressure, temperature, and timing.
So your time.
So temperature, if I don't get airflow, that's temperature. Temperature safety has said, hey, I'm gonna open up the circuit so we don't tear up the equipment. Safety circuits in series, either in heating or cooling, are put into place to save the equipment. But you keep running it and running it, you can make a limit, cause a limit like this to just open permanently because it is cycling. We call cycling off the limit. Since it's an automatic reset, what is it gonna do? It's gonna heat up, open the switch, system goes off, and when it cools off, it's gonna close again. And it's gonna keep doing it, and it's gonna cycle off the system. In this case, you probably will smell that. You'll smell that. It's gonna be kind of dusty, funky, like, you know, you can smell that. And you will also see on some of your supplies, I look at them in restaurants all the time, you're gonna see dirt.
All around.
When you have a dirt, it's gonna be dirt all around there. And that's that dust trying to squeeze by an open place. So if I go there, I don't sit up under there. I say, man, every time that furnace come on, it's gonna go poof, and blow a little bit into my food. It is. You always,
Yeah,
that's
that's
what it's
true.
doing on Valentine's Day. That's
My
what it's doing.
restaurant got that shit.
Oh,
It's
no.
gonna be blowing
Like
in your
that we don't
food.
use, you can see
Because
like black
people,
pieces.
and when I say you a PM company, if you
Oh,
a
got
PM
the
company, and
100,
you doing
it's
like
cleaner.
light commercial,
That's
you get your
31 on
ladders and
top.
stuff,
So
and you clean that off with a little rag and dust, and you get all those vents. It pays money to do that. Cause you know service tech's not gonna do that. They're gonna change that filter, they're not gonna wipe that off. Ours are required to. Ours are required to, because it's part of service. It's visible, and it's nasty. And if you change that filter and don't wipe that off, I'm not calling you anymore. I'm not doing it, because that's part of the service. That's part of the service. But this one, you will see it more often than you want to. Sometimes I take a big screwdriver and I have to cut all that mastic because it's sealed and pry it up and stick my light in there and look up in there. And that's what you're gonna see, you're like, oh boy. But what is it gonna cause? In the heating season, the furnace is gonna heat up, it's gonna cycle off because of air restriction and build up heat in the heat exchanger. It's also can cause the furnace motor to burn out because that filter is in front of the motor. So now all that dust is in the rear end of the motor where it has all those vent holes to circulate the air to keep the motor cool. It's gonna burn up the motor. So you said, what is the result of that? It's lack of preventive maintenance for a long time. That's 2 years or more. That's 2 years or more. Usually on rental property. So if you get assigned to a rental property and you have these kind of problems, in the summertime it's different. Because what did we say that heat goes from what? Warmer to a cooler. The return with a filter, that's the warmer. It's drawn through the air handler and it goes to the A-coil evaporator, and the evaporator, which is colder, absorbs the heat. So air condition doesn't cool because it blows cold air, it removes heat. So if I can't remove heat, am I cooling?
No.
What does it look like? The coil, the A-coil or the evaporator, say 40, 45 degrees or so, cannot absorb heat. It gets colder and colder, colder and colder, colder and colder, and starts to freeze. It freezes. A compressor is a vapor to vapor pump. If I don't get vapor and liquid goes back to the compressor, it's gonna damage the compressor and probably you're gonna have to replace it. It's gonna ruin the compressor because the compressor wants vapor. And all of this was because what?
Yep.
Yeah, they
preventive
wanted to
maintenance.
change the filter
Yep.
because he wanted $110 to change. I'm paying no $110 to change no filter, okay? The compressor gonna be about $2,200. And cleaning the coil and all of that, you're gonna be out of a lot of money. You're gonna be out of a lot of money. And unfortunately, a lot of this is in our business. That's why you see companies having service contracts, annuals, semi-annuals, some once every 2 months, once every 3 months, twice a year. They call it a startup when we start up air, a startup when we start up heating a minimum of twice a year. You won't see that. You won't see it at all. Only time I saw it that was quicker was an apartment complex that the young mother was very clean, and she swept this carpet 5 or 6 times a week, and she was sweeping it in the hallway near the return. So all that dust was sucking up in the return, and it did that to her coil. It did that to her coil. Because they took the filter out.
So it can burn out your compressor?
If liquid goes to the compressor's vapor. There wants no liquid. And some of them have what we call an accumulator that will collect the liquid and kind of like boil it off, but not that volume of liquid before it goes into the evaporator, but not that volume of liquid. And it's very noticeable because when you look at the A coil right there, where it connects to the furnace on the upper part, the case coil, you'll see ice that big. It's either low on charge or airflow problem. What do we say those for? You got a refrigerant problem or airflow problem. That's the problem. Low charge or airflow problem causes that, or a restriction. The restriction could be airflow, the restriction could be refrigerant, the restriction could be a bent line, a restriction. And then it has other behaviors because of restrictions depending on where it is. Is it time for your break?
Yep.
Go ahead. We come back to this and then we go in this room. They all have a specific job to do, or a specific ability to change the operation of a piece of equipment. That's all they do. They can make it space age if they want to. It still has to work primarily under those 3 conditions: pressure, temperature, and timing.
Very low speed, up to 100% of their capacity. Being able to dial in the desired speed precisely makes them the motors that are best choice for all types of advanced systems. And just as a side note, for folks who live here in Sacramento County who might be looking for rebates available through our local utility company, SMUD has verbiage in their new rebate structure, and this is in 2021, so double check those rebates, that the new rebates revolve around furnaces and air handlers that have variable speed motors. In this case, ECM variable and ECM constant torque motors are the same to SMUD. But in the real world, when we're talking to each other about these 2 different motors, it's constant torque and variable speed motors. So let's expand a little bit now on the differences between those 3 motors. PSC motors. Ever heard of Nikola Tesla? I'm sure you have. He's the inventor of the first practical design of the split-phase induction motor. He made them easy to use, low cost, and compact in design so well that the industrial market started using them more and more. They got to be so useful, home appliances started using them in a variety of ways, like heating and cooling. While simple to build and low in cost, they are being drowned out by today's modern high-efficiency motors. 3 or 4 high-voltage wires control the speed of the motor. They're pretty simple to switch out. They're usually like a high.
Are you aware that the colors of those split-phase motors represent these speeds? And they're always representing those speeds. Sometimes you use low speed on the furnace, but you might need medium low, or you might need medium high because you need more airflow because of duct design. Yes.
Will you read this and it tell us the colors for it?
Yes.
Okay.
Red is traditionally low speed for heat. Black is traditionally, as they say here, for cooling, because cooling air is heavier, you need more force to push it, more CFMs. So that's the traditional hang connection, and you don't use all 4 of them at one time. You only use 2, one for heating, one for cooling. That makes sense?
Yeah.
At a time. The other ones you park. It says park on the board. You just stick it on park, it has no connection. It's just not swinging as out there.
Medium high, medium low, and low tap attached to these blower motors. When that winding receives 120 volts from the furnace's control board, it starts up at that speed. But 120 volts isn't the only thing that's needed to start that PSC motor. It needs a capacitor to provide the energy to get that motor up and running. The capacitor winding stays in the circuit the entire time that the motor runs, which is where we get the P in PSC for permanent. The S in PSC stands for split, because it's a motor that uses single-phase AC, which has been split by the utility into two equal proportions, just in opposite polarities. And then C is for capacitor, which, as we already know, is the storage bucket of energy that the motor consumes to start and run efficiently. The reason PSC motors are getting phased out is that they build up heat, which decreases the motor's efficiency. This earned them a rating of 60% efficiency. But hey, that's been the standard in residential heating and cooling for a long time. If there are restrictions in airflow, like undersized ductwork, dirty filters, or dirty evaporator coils, PSC motors start to lose performance. They deliver less air because they tend to bog down, drawing higher amperage. The system's static pressure, or blood pressure of the system, builds up and fights back against the PSC motor, wearing it and the capacitor down through overheating. PSC motors aren't the quietest motors either. In fact, of the three motors that we're discussing today, the PSC motor is the noisiest. Having said that, PSC motors are the least expensive to buy and repair. The next two types of motors are much pricier to repair or replace. ECM constant torque motors. Probably the most familiar name in ECM constant torque motors is the X13 motor by Gentech. Gentech acquired General Electric's Motors and Capacitors division in 2004, and in 2009 renamed themselves Gentech. I bring this up because the first high-efficiency residential HVAC ECM motors were made by GE back in the 1980s. Even though they're like upgraded PSC motors, they're a little bit more complicated in design because they use an integrated control board to send the signal for operation and at what speed or torque setting to run at. Because of this, they're more expensive. Not quite as expensive as variable speed motors, but significantly higher than PSC motors. X13 motors were designed in 2006 to achieve higher SEER ratings for the air conditioners being put into homes. The government set the standard.
What does SEER mean? SEER rating, what is that? Seasonal, energy efficient rating. And that's what the government uses to determine that the best components are in a machine.
Seasonal energy
efficient rating. And it lets you know seasonally how much kilowatt usage that motor uses and what it costs to a customer and what any kind of savings is for that particular item. And you really can't tell until after the season, when you see how much you paid to run the electrical components like air conditioning. That you can tell after the season. That's why they call it seasonal. You have to run it throughout a season. And that's for compressors, furnaces, and everything now, because just like now, it was first it was 10 SEER, then it went to 13 SEER, then it went to 16. Now the government is saying they want 17, 19 SEER to use less power off the power grid, and you get more machine value and lower utility costs because you're not using a lot. So to tie in a little bit, I'm not gonna do a lot of it, but to tie in a little bit of what we said this morning about a restricted evaporator, if air doesn't flow through, the air, as we said, that is going through the return goes through these vents that help cool the motor. So if we can't cool the motor off, the motor builds up heat, it can fail and becomes less efficient. Every motor that's moving, pulling amperage, has to be cooled off.
Standard, so the industry has to keep up. The SEER rating that they were trying to achieve at that time was 13, thus the name X13 motor. So what does constant torque motor mean? As the system gets dirty or ductwork is too small, maybe the filter hasn't been changed in a year, the system's static pressure or blood pressure will increase because it's becoming restricted. So just like the PSC motor, it'll start to decrease in the amount of air that it can push out, but not quite as drastic as the PSC motor. As much as 20% less impact on a semi-restricted system. When the airflow decreases on air conditioning mode, the system can freeze up with ice and completely restrict airflow. While in heating mode, low airflow means that the system can overheat and shut down, wait for itself to cool off, start back up, overheat, shut back down, and over until it completely locks itself out. So with a constant torque motor, the chance of the system shutting down because of airflow restriction is less because the drop in airflow produced isn't as drastic as with the PSC motor. If you decrease the amount of air that a PSC motor moves because of dirty ductwork, dirty filter, or dirty system, it'll use less power and not deliver the same amount of air as if it were clean. It's not a smart motor. In the same situation, a constant torque motor will increase its power output to the shaft, which spins the wheel harder to try and maintain more airflow through the duct system, preventing those issues that we were just talking about. And there are safeties programmed into the motor to prevent it from destroying itself if airflow gets really bad. So the power block to the constant torque motor receives a high voltage and a low voltage signal. The upper portion of the block has connections for the high, and the lower terminals are for the low voltage taps. So instead of having high voltage determine the speed like on the PSC motor, low voltage taps are plugged into either the 1, 2, 3, 4, or 5 terminals, which have been pre-programmed to a specific torque setting by the manufacturer. And only some of those taps may have been pre-programmed, so maybe only the 1, 2, and 3 terminals work on the low voltage side because the maker of the air handler decided it to be that way. A constant torque motor is a brushless motor, which reduces heat within the rotor and stator area. They're 80% efficient compared to the PSC motors, which are rated at 60% efficient. They also don't need a capacitor to start and run. They have integrated electronics built into the motor, which means if either the motor windings or the circuitry goes bad, the whole motor has to be replaced. Okay, ECM variable speed motors. GE, which I said before, was acquired by Gentech on the motor side, introduced the first variable speed motors for use in its HVAC systems in 1987. So it's not a new technology. So, you know how when you get your car on a 100-degree day and set the AC with that auto button to reach 70 degrees?
Right.
Well, when the car first starts up, the AC fan turns on about as high as it can to match the cooling effect that the system's trying to produce. Then, as the system starts reaching that 70-degree area, you might notice that the fan starts actually ramping down little by little because the demand isn't as high. Once you reach 70 degrees in the car, the airflow doesn't really stop, does it? No, the air stays on lightly, keeping you at 70 degrees. All the while, you haven't touched any knobs to control that. You notice how that motor ramps up and down instead of the constant torque motor and the PSC motors that have set speeds for specific demands from the thermostat? Variable speed motors can fluctuate between very low speeds and high speeds with their brushless design, which helps maintain an impressive 80 to 90% efficiency rate. When airflow in a variable speed system becomes restricted, airflow stays the same, constant airflow, because they've been programmed to know exactly how much torque and airflow that the system needs to function properly. Constant torque motors can only apply a little more power to the blower wheel in an attempt to maintain the airflow needed by the system.
Okay, so I'm gonna stop this for today doing these. We're gonna go to chapter 17.
So that's just a little stink piece on the difference between motors and ECMs are here to stay, as well as variable refrigerant flow, which you haven't heard a lot about. That modulating motors keeps a motor from running 100% when not necessary. The ones running 100% will cool, will work, but they use a lot of energy. and energy use is a cost to you and the customer. So ECM motors, variable refrigerant flow compressors, ECM motors can be found in furnace, fans, fan motors, compressors, furnace fans, and condenser fans outside. This is residential. So we're modulating the air in order to cut down on energy use. And these are words that weren't here in residential for a while, maybe 6 or 7 years for variable speed on a compressor, variable refrigerant flow. So if we can vary the refrigerant flow, we can vary it by how a motor pumps, because a compressor is a motor. It's a vapor-to-vapor motor pump. So all these systems you guys are gonna start seeing during your career, you're gonna become very familiar with this. And in commercial, we call it a VFD. Has been out for many, many years, and ECM, as we have learned, is a process of taking AC voltage and changing it through electronic head. This is the electronic head. These are the low voltage connections on the lower part of the motor, and then the AC side will be on the top part, or the top part on the motor connections. So commercial uses 3-phase, which means all the phases are what? What are they? 120, 120, 120? Are they what in phase? They're what? Do we handle phase yet? Yes.
What is
out of
that?
phase.
I can hear.
Tell them again. And so we'll cover that too. And so you don't need any digital change to make the motor change speeds, because it's already 3-speed. Commercial's been using it for years to control pumps, to control fans, air handler fans. It'll speed up and slow down based on frequency, which is what? What is another word for frequency, do you know? Hertz. 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 So 60 hertz would equal what percentage of the movement of the fan, or the motor, or the pump? 100%. 100%. So anything under 60 would be a slowing up of the motor, and it would be controlled by the hertz through the circuit, through the frequency drive. And the frequency drive is another component that is tied into pumps and tied into motors and air handlers that controls through frequency the speed of the CFMs of a particular pump or motor. How many gallons per minute it pumps, or CFM for the airflow coming through a unit. So residential said we could benefit from that, but you can't do that with single phase. And so one of our brilliant engineers said, you know what? We can fool, and this is on one of the tests, we can fool single phase to think as 3-phase by taking it through electronic module, converting it to DC, and DC can change the speed of a motor, and it won't know it. That's kind of brilliant, that someone actually read the kind of books and understood how to do that. I always think so. And we can change the speed and get the same effect. And I say that because I've noticed over the years, it's been a while, but it's gradually changing more and more, how controls and operation of residential machines mimic commercial. Residential was put a fan motor in there for 1750, boom, let it rip. It's 1125, bam. It starts off, it runs off of that capacitor, and it runs at high speed. So the industry said, well, if we are set it at 72 and we're at about 76, we don't need all that airflow. We can slow it down a little bit. We can slow that down and still get the same amount of cooling. And so in recent years, ain't been that long, they said if we can slow the motor down for the air handler, we can also put a package on the condenser fan motor to respond the same way, and the compressor can be a 2-ton to a 4-ton, or to a 1.5 ton to a 3-ton, based on the load in the house. So we have to have sensors, we have to have a bigger card. The card on that condenser, is, I'll show you, is gonna be 4 times this size or 6 times this size on the condenser. It's very intimidating to look at it. You look at it and back up. What am I supposed to do with that? Every time we have electronic devices, it's not to intimidate, it's to control. The more I want to control, the more programming has to be on that card. The more programming and devices that we need to make a program and a sequence of operation work in a certain order, the bigger the card gets. It'll probably get smaller in the future, like cell phones, but the bigger the card gets, because it's controlling more systems, more operations, more inputs, and delivering more outputs. That's how that works. A lot of people don't talk about ECMs because it seems like something that they feel is not part of the real world of HVAC, and it is. Those PSC motors are still there. The book talks about several different types, doesn't it? What else are they talking about? Permanent split capacitor, shaded pole. What's a shaded pole motor?
It's like the poles that they use in swimming.
Do they have a shaded pole? Do they have a capacitor? Yeah. Shaded poles have a capacitor?
No, they have reversible wire on the state, small wire.
Small motors, like in your refrigerator, upper part fan, little fans that you get at the park. Shaded pole. They don't need it, they're low torques. They don't need it. Very low torque. 3-phase motors have 3 lines, L1, L2, L3. They're mostly used on commercial equipment, air handlers, compressors, any high voltage, high torque type of machine.
It's gonna have more,
commercial.
it's like if it's higher torque, it's gonna have like more like a 2 capacitor instead of just
3-phase does not need a capacitor.
No, I'm not talking about that, I'm
Oh.
saying in general, right, if it has to have more energy, it's gonna have 2.
If it's more motors that are PSCs, the larger the motor, the larger the capacitor. So these blower motors, or some of the motors on these small 3-ton condensers, are between 5 microfarads. Some of them a lot now are 7.5 microfarads. They've gotten more microfarads capacity over the years. It used to be a guaranteed 5. Now you can see 7.5. And they also have other information on the side, which you'll see on some 4040, 370 VAC, 440 VAC volt amps currents. Some of them are larger for more torque motors, and you have to be careful to look at the VAC that's on here, volt amps. That's the marking of what the motor can handle, the size, the voltage, and the torque.
When we get to a call, and when we get there, we're gonna read the motor, so it doesn't matter what type of motor it is, we're gonna read it and have the information on it, correct?
If you need to, if something's failed on the motor, you'll have to take the motor out, and it's usually in a band or mounted on the condenser from the top or 4 volts. You have to remove it. Sometimes you don't have to remove it to get the information. Cell phones have made some of that pretty easy for us. But you have to know several things about a motor.
That's what I'm trying to get at. Like,
It's
what's the
not
most
just the
important?
voltage, it's not just the amperage, it's also shaft diameter. How big is the shaft? Because the shaft is gonna fit into a blade or fit into a housing of an air handler. And the hole in the housing must fit this. Also, motors have a diameter that fits in a spider bracket or a bracket made for that motor that wraps around. If it's a band bracket, some of them mount upside down and have 4 bolts coming out the back that actually mount to the top of the condenser. Others have, for some air handlers, and like commercial, will have a cradle. And a cradle is a component that the motor slides in, and then you use clamps to hold the motor in place so it doesn't jump out the cradle when it's there, so you can have a permanent position for that motor. And it's gonna also have, in many cases, it's gonna have a belt-driven air handler to a belt-driven motor, and they're gonna have pulleys on both ends. Do you know what that is? Belts. If you have belts, you have pulleys. The smaller pulley goes on what? It's gonna be 2 pulleys. The smallest goes on what? The motor. The largest is gonna be on the air handler wheel.
You said the smallest going what now?
The smallest pulley goes on the motor.
Okay.
The larger one is on the circulation distribution wheel that's pushing the big blades that push the air through the duct.
Okay.
So belts have to be a certain size, pulleys have to be a certain size, and then it's certain math that you get a ratio of how many turns you get out of the smaller motor compared to how many rotations come from the big one, and they call that a ratio. And so if I had a 12-inch pulley and if I had a 12-inch pulley and a 4-inch pulley and a belt that goes around it, this one is gonna be on the air handler attached, because the motor, the air handler also has a connection on the distribution wheel to attach the pulley, and this has a pulley, and actually the motor will be attached to the back of it, and it would have a shaft going through. So if they wanted to know the ratio of that motor, 3 to 1. It's 3 to 1. 4 goes into 12, 3 times. So what does 3 to 1 mean?
So it will take 3 times before it makes 1 second.
For every 3 times, for every 3 rotations, this one turns 1. So that little motor going, and the air handler going whoop, 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 whoop. So it can go faster and faster and faster, but the ratio remains the same. You'll find those in the market and commercial a lot. Belts have to be aligned, they have to be absolutely straight. Tension on them, there's a tool called a belt tension tool that you can see the type of belt that's on it by the numbers of the belt, the pulley size, and you can put the tension device on the belt and push down, it tells the tension, and you can set the belt to the tension that the manufacturer recommends for the length of belt, the type of belt, and whether it's a cog belt or a B belt or a belt, and you can determine the proper tension for a belt. Because if you ask 9 out of 10 techs or mechanics, they're gonna say, how do you adjust a belt? Some of you may have done, how would you adjust a belt? Some, like what? With what? I'm not talking about with the tool, I'm talking about how would you adjust it?
You would just by sight.
By sight, so you can do that by sight. I've seen guys take a ruler, straight edge, I've seen them take other instruments and say, oh, it's straight. But the pulley has to be straight in total alignment. So if you was looking at them from two pulleys, and the rear one was here, and you putting a belt on it, it can't be this way or that way because it'll wear on the belt. It has to be perfectly straight for proper operation. It also has to have the correct tension. And tension is, if we were looking from the belt like this, is that belt going there? Is it sagging like this? Or is it straight like this? And so 9 out of 10 mechanics would probably say, I look at the amperage on the meter, I take my amp meter and I tighten it in the saddle and pull that belt tight until it falls into the numbers of the amperage of the motor. Not true, but 9 out of 10 techs that I know, that's the way they do motors. And there's another group that just pushes on it. Feels kind of tight, that feels kind of right. Well, how do you know that? Well, that's how I always did it, that's how I was taught. It doesn't mean that that belt is pulling and sitting on those pulleys in the correct manner. So you must use a pulley tension adjustment tool for that particular belt, for the length of that belt, and to see what the tension, because when you get correct tension, it might be like this. And if you did it by hand, you would say, oh, that's too loose, but it's really not. There's actually a one-day school on tension of belts, because it's that important. Some people have belts hanging all on systems and they change them constantly. They just keep 5 on there, just keep putting them on. Never tighten a pulley, and a belt must ride at a certain level in a pulley. It can't be digging all in the creases. It has to ride lip to lip on top to pull or to slip. It has to be the right kind. So we use cog belts because cog belts are not like a regular belt that is smooth like this, right? A cog belt is gonna be like this. It's gonna have brakes in it. They cost more. They are manufactured differently. They don't bake them till they get hard. They have a different process for cog belts, and because it has creases in it, it grips, never slips. Never slips, a cog belt. So those are your better belts. But those are on your belt and pulley systems, usually 7 tons commercial and above.
The difference with the motors is the windings, so if it's 2, 1, 3, it's just the windings, right?
Well, the windings or the poles, you mean?
Yeah, but it's the
Poles
same
determine speed. So poles are what you're looking at in the end of a motor. Those are poles. Some people call them windings. But they're actually poles. And if you can count the poles, you can learn how to count the poles, you can determine the CFMs of that motor. And so the slowest speed would be what winding? Would it be bigger or what?
Bigger, he said bigger.
Because the more resistance I have, what? Is it slower or
Slower is
faster?
gonna go.
The less resistance is gonna go what?
Faster.
The more resistance,
Slower.
slower. So those are some of the things about motors. Some motors need capacitors, like the PSC needs a capacitor in the circuit.
That's why, like the video said, permanent split capacitor, it has to stay in the circuit in order for the motor to run. It needs it to run all the time. Three-phase doesn't need any. ECM doesn't need one. Yes.
Can you show us with the pole? Yeah, I'm like.
Well, this one is
Is it
different,
copper?
but the poles are in there.
That copper
But this is,
in there?
yeah, that's a variable speed motor though. So since it has a lot of speeds and the poles represent speeds in an older type motor, it would have maybe 6 or 8 poles in the bottom of it. And I think it gives a good drawing in that too in your book about the poles.
407.
Which book you in, 407? And it has a picture of the poles and how you determine what the poles are. It actually shows you the poles. Because this one, I like the little book because everything we mostly talk about is in here, like, the ECMs. It has the greatest information on ECMs, and we're talking about, I think it's in chapter 8 about ECMs. And it breaks off talking about the motors, start capacity motors, three-phase motors. So I do like this book because it does break down all the components with great pictures. It just doesn't throw it at you like in the big one.
It's called them winding too on four or something.
Some call them windings, but we call poles how you can determine the speed on the pedal. That's three-phase, and this one is starting on chapter 8, and that would be electric motors in your black book. And it has great pictures, that's why I like it. I wanted to see that one, they done took that one out, I guess. And so, windings of electric motors, they speak of it that way on page 178 as well. And when you look down at the windings there and poles and types of electric motors, how you determine speed by frequency and hertz. So it gives a good one, four pole on page 179. So that's the first one I see them mentioned at the bottom, 4-pole motor speed that you take if you want a 4-pole motor speed, will equal 60 hertz times 120 volts. And you get, you take that answer 60 times 120 and divide it by 4. So if you look at the bottom, 2 poles are 3450 RPMs, 4 poles. The more poles, the slower the motor is. And the poles are what you see as groupings of windings.
Is there more torque with the slower motor?
Well, torque is determined by how the motor is constructed. The poles, the windings, the electric, the amperage, how the motor is constructed determines, and the use determines the need of the torque in the motor. But they all have torque, especially if it's a TSC motor, or they all have a torque factor in it. Constant has a torque, a constant torque.
So the different things between motors would be stuff like if they have a capacitor.
What is it used for? Is it a motor for a fan? Is it a motor for a compressor? What is the motor being used for? What is the size of the unit? What are the flow rates of the motor? What is the CFMs required for the air handler? What's the application of the motor? It's gonna get beefier. It's either gonna have a motor starter, looks like a giant contactor, because it's taking more voltage on it. So the beefier the motor, the more work we ask the motor to do, the larger and more torque that motor's gonna have, the more work we ask that motor to do. Work is the size of some air handlers can be as large as this room. And they could have a blower
from that board to here. So it has a large 25 horse motor or 50 horse motor with a bolt in the top of it so you can take it off with a chain. And those motors are made for higher torque or higher demand, because you can imagine in a floor of a hospital how far that air handler has to flow that air in so many different locations. It has to be a very powerful motor. But on air conditioning and furnaces, it's kind of simple, very simple. Most furnaces, residential, is not gonna be over 150 BTUs, that's it for residential. If you need more, you're gonna have to put another additional furnace in. The condensers are not gonna be over 5 tons for residential, that's what it's gonna be. So you can always see what kind of motor you're gonna use, cause it's 5 tons, from 1.5 tons to 5 tons. And the furnace is gonna be probably from 40,000 BTUs to 150,000 BTUs of heat. So you can determine the airflow for heat and determine the airflow for cooling. And then when we go in the lab, you can look at the nameplate, and it'll tell us on the nameplate what is the design airflow for that furnace. 18, 25, 12, 50, 14, 75, or whatever it is, it's gonna have for that particular furnace, designed with that particular air distribution wheel, with that particular motor. This is the maximum airflow you're gonna get out of it. If you need more airflow, you're gonna have to get a different furnace design. So if I have a distribution wheel that skinny or 8 inches, you're only gonna get so much air out of there. But it must be a very small system if you're trying to heat this room up. If I need more, that wheel's gonna start getting wider and bigger, because you have to deliver, the motor's gonna be bigger. It's gonna be mounted on the side, as we'll see in the lab, mounted on the side of the frame of the distribution assembly, and it's gonna have 3 screws in it to hold it in place, and the motor will go in the middle of it to hold it in place, and then the shaft will go into the air distribution wheel, so it'll be locked in there and balanced. Then you have to make sure it's the same distance on each side, so when you plug it in, the motor in, it does not rattle or it does not move in any direction except straight. I normally take an extension cord, hold on to my distribution wheel, plug it into my cord, and make sure it's running straight before I take all that time putting it back in the furnace. Then you gotta take it back out again. Make sure it's level and even.
Is that, the torque wrench, so was that what would be the
A
adjustment
torque
tool?
wrench. A torque wrench is a tool that we determine TR torques wrenches, a tool we use to determine how tight you want to dog down a screw. Instead of taking a power tool like you can make it too tight and break it. And usually when you use a torque wrench for a particular component, you also get a direction of what screws or bolts to dog down first. It's not always 1, 2, 3, 4 to 9 or 10. It could be 1, 2, 3, 4, 5, 6, 7, 8. They give you a direction, so when you tighten it, cars are like that too.
With the wheels?
Putting manifold covers on, you know, everybody goes, but you're supposed to torque them down. And torque does not mean, torque means exactly what they say. If they say 6, the torque wrench has an arrow on it with numbers like a ruler. And when you pull that arm back, when you get to 6, that's it. I don't care what you think it should be, that's it. You don't torque it anymore. That's what a torque wrench is for.
Okay, I know, for the torque of a motor.
No, the motor
Okay,
is
okay.
controlled by the design of the motor, the stator, the shaft, the windings, the poles, and what it's gonna be used for determines the strength of the power of that motor. for what you're trying to pull, because remember, the motor's pulling a load. So depending on the load, that's what determines how that motor is built and the torque's on, depending on the load. You can't put no little one, you wouldn't put a Volkswagen engine in a tractor trailer. It ain't gonna pull it long. It might pull a little bit, but not long if you could do that. I guess if a person can pull it like this in a strongman contest, it might move a little bit, but I doubt it. I'm just using that as a fictitious example. When you have a load, you have to match the motor's ability, capabilities, and specs to deliver the speed, the CFMs, cubic feet per minute, and the feet per minute for that particular motor. And it's designed on what are we using it for. A lot of times it changes, and that's why some of those frequency drives are kind of cool, because they can adjust that speed. If you ever see one operate, it'd be going, ooh, they call them, you know, why you need a capacitor is because what? The need of a capacitor. Because you're going like a drag car, like a drag strip car, and you go in that speed, whatever it is. And so when a motor starts, it's drawing pretty much 80% of lock roller for a split second. And then the motor comes up and running, and it doesn't have that demand on it. But you have motors now that are soft starts. Hard start is drag strip, takes off. Soft start on a variable is like, that's how they run. And then it's wide open once it gets going. Don't stick nothing in there. And you can, if you see the belt kind of slagging, I know this because I did it. I put a broom handle on it because I got a good idea, right? And it was sagging and dragging, so I touched it on the top the first time, and the motor took off. Ooh. The second time I did it, it threw that broomstick back at my head like Tarzan. I never stuck another one in there. I'm always doing something like this. This is the drag on the variable. Variables are out here on every piece of equipment almost now that you have. They work a little different in commercial, but in commercial and residential, but they have the same effect. So you're not gonna see you'll still see PSC motors around for a long time because they're cheap. These motors might be $1,500. But I noticed the one he showed because they were so expensive at first, the next group that came out like this, where you can actually take the bottom off and replace the module. So the module might be $400 and the motor's good. When they first came out, the module and the motor was one piece. You had to buy the whole thing. Nothing was even wrong with the motor, it was the module. So they have made upgrades and changes on those pieces of equipment, and it'd probably be a little better to see how they actually work. The one unit we have that's variable in there, sometime I take a blanket and wrap it around that condenser fan motor will be flying, and you block it off. When it reaches almost set point, the motor will be running like this. You can see it. You'd think, if you're just used to PSCs, what would you think? That motor's failed, wouldn't you? You say, that's the problem, the motor not traveling fast enough. But it's nothing wrong with the motor. So as that load increases, it's gonna change the rotation, not the rotation, but the speed of that motor. And when you see it in action, it makes a little more sense. Most of the motors you have are gonna be PSC, especially in the lab, but we do have 5 ECM motors in the lab as well. And 1 variable refrigerant flow unit right now in the lab. And when you see how big the car is, it's gonna like blow your mind, because you're just gonna be intimidated by it like everybody. You're gonna learn how to replace the motor, how to remove it, take it completely out the housing, put it back in there. Most of the time, it takes me longer to put the whole assembly back in there on that little rail than it does to fix the whole motor. I usually give it to my helper. I said, put this in. I can't do it. I don't wanna do it. cause it has tracks that you have to be perfect or it keep falling out. And it slides in there, and then you pop a screw in the top, so it doesn't rotate through running, slide out. So it's just one screw that holds it in place. 2 brown wires on the hose, the 2 brown wires are left. On a motor, regular motor, PSC, what's the 2 brown wires?
Capacitor.
Capacitor. One goes on one side, the other one goes on the other side. Then you have the colors that you saw, red, blue, black, white, yellow, and red. I said red and yellow, and those are the different speeds that you can have for that particular motor, from low to high, and anything in between. Those are the majority of the motors that's out there. So there's another video we're looking at another time, how to test a ECM motor, because it's not the same thing. You have DC coming out on the lower part of the unit, DC, and then AC feeding. So if you have the DC, you know you have the AC. And since you have digital boards, it's always controlling some function of the motor. So you don't know if the car has failed or the motor has failed, and there's ways we can test it.
Does it matter which the brown, wires on capacitor, which side, which?
Doesn't matter. One is gonna be brown, one is gonna be brown striped on these type. 2 brown wires coming out, they go on either side, on this one. Either side. The rest of them go to the board, and one is gonna be, the speed, and then L1 goes on the other one of the board, and the other one will be on the speed. This is gonna be neutral, so the neutral is gonna go here. For everything neutral is gonna go to the neutral. Everything gonna go to that neutral. And so the other one is gonna go, you have cooling and heating. EAC is electric air cleaner, and you have a L1. You have cooling, which is gonna be high speed, heating, gonna be low speed. Does this one have a park on it for the ones you're not using? It doesn't have a park on this one, so you have to, yeah, it does, right there, it says park. See where it says park on it? The speed you're not using, you just take the spade and plug it in. And there's no connection to that, it's just to keep the wires out of the way. And that's where you plug them. You only plug into the board for heating, cooling, the speeds you want the motor to rotate in heating, and the speed you want the motor to rotate in cooling. What questions do you have? What? Well, it sounds like I need to get my laptop and ask the questions for the training.
Oh, shit.
That's the problem though, we gotta be consistent in everybody. All these different models, you could have thought of anything.
I'm probably falling asleep. That's why you asked him.
I know pay attention.
Oh, no.
I think chapter 8 would give more information. Do y'all see all that stuff in chapter 8? It's more information, right? Am I tripping?
Shit.
Can I ask about the midterm? About midterm?
What do you wanna ask about? When is it coming or something?
No,
Are we gonna get a study guide?
Yeah, definitely. We need one.
Well, I got different thoughts and study guides. I do for some classes, sometimes I do for this one. So the more study guides I give you, the different variety of questions you can have, right?
Right.
So we'll have a couple quizzes leading up to the midterm. Because that way, you know, if I give you all the answers, I don't know if you know it or not. You just got a good memory.
do you know what units are gonna mainly be on the midterm?
I'll let you know.
I mean, it says it on the.
He knows what units.
I'm gonna pull it up for you. Don't make no mistake about it. Let's see, this is daytime.
Like 17 to 20 questions.
Most likely I got that.
I'm
not in that class, but so. I'm not in that grade book. But I need a 100 grade book, this is 100.
Mr. Harrison, we just discussed, what's this, centrifugal switch?
I mean, none of that. You got a relay, we didn't talk about that?
You talk about your relay.
No, what he just said, on top of.
A centrifugal.
Centrifugal.
That's the word.
Page,
How does it work?
412,
How does it
413.
Don't read it,
It's
read
got
it.
a weight on the inside.
As the motor picks up speed, it does what? When it hits top speed, what does it do?
After 75%, it cuts down, cuts off and then the capacity.
And what else? How does a relay, did it talk about potential relays as well? That's more on refrigeration, most of yours would be fan relays. Cause you asked about a relay, didn't you?
Potential.
That's the dangerous lab.
Yeah, we talked about potential relays on Fox.
Mhm. Potential relays are used on larger equipment and on refrigeration equipment, like coolers and freezers, on those type of compressors. And the biggest thing is what terminal is the coil on? You got 1, 3, 5, 2, and 4, or 2 and 5. What terminal is the coil on? The coil as there's 2 sets of contactors. That's not a potential. That's just a normal relay with several contactors normally open and normally closed. Because this is one thing that's true too. Like in the lab, we use a 4 or 6 contact connector or 5. A lot of times I use these kind because the switch doesn't care if it's exactly that type in a jam. I'm looking for what terminals are normally open and which ones are normally closed. So I can connect my wires to normally closed and normally open terminals and apply 24 volts to the circuit, and it'll work.
It's 2 and 5, because it's wired between 2 and 5.
2 and 5, so if you took your meter between 2 and 5, that's on the circuit test too, in 3rd semester. So the coil is between 2 and 5, what would I expect to
The
read?
coil is wired between terminals 2 and 5, it's the light, it's 718 on 420.
That is a test question.
Well, if it's voltage, I'm not using 24 hertz.
The coil should close. So if we're testing a potential relay and we're testing it to see if the coil is adequate, we would get what if we would get a known resistance between 2 and 5, a known resistance. And then the other, we always have a set of contactors, contacts that's normally open and normally closed. If we want it to close when the coil is energized, then we want a load to operate. So relays are pretty simple in that way, that we have a coil, 24 volts, normally open, normally closed. Some of them are just straightforward 4-pin relays that work a certain way, and it goes power in and power goes out to the load. So when the relay closes, the fan motor runs. Have you done that in lab yet?
I've done it, but my question was, it was using, on the board I had, use this instead of the smaller one, so it wouldn't give you the right reading.
What reading, you talking about amp reading? Or what reading? Let me see.
This one,
You always have to read what's on it.
yeah, but that's what's
That
the
one,
one that
other
was
way.
described in the lab.
Other
It
way.
was telling me you
Oh,
use
that way. Oh.
1 and 3 for the coil, but that was a type of coil.
What are we looking at?
No, this is what I'm saying. If it says coil, then you look at where the coil is on the relay. And the coil would be here.
Yeah,
So the heck with 1 and 3 is, this is the coil. And you can always take the coil by putting ohm reading on it. That's the coil. So sometimes you don't have the exact replacement, but you can have the exact operation. And so if you put the here and you're looking for normally open and normally closed, 5 is, what did you say?
it would be 2 and 5 or something.
2 and 5,
4 and 5.
4 and 5 is normally closed. And 4 and 5 and 6 is normally open.
And you reading it, correct?
Yeah, I'm reading it right off of there. It shows the switch, whether the switch is open or closed. That's all you have to read on it. Whatever you want to be normally open, that's what you connect it to. And it won't close until power is applied. So if you put it on normally closed and the motor keep running, that means you don't have no control. It's just jumped through a relay. That's like jumping, and you want normally open because you want to control it. And it's not under control if you put it on the normally closed. It's not controlled if you put it under the normally closed switch. Yeah, that's a good question. But relays don't have to look the same. When I put them in the lab, I said read the relay. Read the relay. You can't always follow the numbers because it could be a different manufacturer that has a different numbering system. And they must show you the position of the switch. Plus you can test it, right? You can test the terminals without power, put 24 volts to it, and see what closes. I do it all the time. That's gonna be normally open. It wasn't no power there before I applied power. When I applied 24 volts, it closed. That's the 2 terminals I'm gonna use. Normally open.
Because a lot of the boards are different, so I want to use that so that the faster.
And I do that to keep people from copying. So I'll make them different. Sometimes I'll put different voltage contactors on them because nobody reads the contactor voltage. It's bad. It's a 120 volt contactor. It's not a 24 volt. They look the same. So you go on a job and you'll be trying to change this and change that, and you have to say it's a 24 volt system and look at the side of that contactor, and that contactor tell you 120 volts. That means somebody before you pulled that part off of their truck, cause it looked the same, and put it on there and couldn't figure out why it didn't run, cause it doesn't have 24, it needs 120 volts to run. Some of those contactors can be used on commercial equipment. They look the same, the exact same. So let me make a list of what you want to do, so I'll make sure I cover it.
Did you ever grade those exams? The practice?
Did.
You did?
Yeah, I did.
How we do?
Y'all asked me that last time. Some people did good, most people did. Nobody did horrible. I'll probably give it to you again to make the grades increase. So sometime I do the test again to make it increase. I'm gonna tell you what I've done sometime, it blows my mind. I'll give you that exam the second time to increase, and I'll come back 3 weeks later for midterm and give it to you again. Some people fail. I said, I'll give it to you again for a midterm because I'm interested in you. Certain information on those questions must be absorbed, like single phase, 3 phase, low voltage, how it is synchronized through a system, parallel, series circuit. All of those need to be comprehended because you don't have to remember everything in the book, but you do have to remember certain items. And I do have because this was one of the first ones you guys had. What was that, my night class? Y'all had this? You couldn't have. You didn't have it. I'm gonna print this for you because it goes along with what we're saying today. And if you want something to study for what we will have, it'll come off of this one. And this is motors and relays, what you referred to, right? Motors and relays. So, for example, what kind of motors have a run capacitor permanently wired in the starter?
One who?
Huh?
Say it again.
A run capacitor?
ATM?
PSC.
so we've been talking about that today, and then we'll talk about, synchronous and actual motor speed. That's a word they use, synchronous. And what is the formula for speed? I'm gonna give you all one, because I think this will sum it all up. This will sum up what we're gonna be kinda needing to know for midterm. Yep, this is the one I had. So it's mostly for motors and relays. I'm gonna get,
Midterm?
this is just, it's more than one sheet.
Okay, now.
Why we been going over the operation of goddamn furnace if we, midterms is motors and relays? Yeah, that's crazy. I thought that was
Wow. Now y'all know what.
Which is high school.
That's why I asked him what materials was gonna be on.
He sleeps on it.
Yeah, if it's about motors and relays, we need to be learning about that, not about the operation of the furnace. That's right.
Yes, sir.
Yeah. Where everybody got. But you know what, bro? We got this group and we can
Relay.
All grades they come in different shapes. I think it's a relay.
Let me see the motors on it. Let me check it out, guys.
No, we never took this one.
I can't see.
Oh, no,
this.
we don't take this one, but we're gonna take 24.
But we should all get 100.
Yeah, 120.
The last one we took
Yeah.
twice.
I think so. At the top.
And you, that's what I'm saying, how do you feel?
Or that quiz or whatever.
Hey, that thing's small, bro. I'm gonna use some reading glass.
Yeah, put these on.
That thing's small.
Put these on.
That might be too much.
So 3 is normally.
Let me see it now, brother.
Let me see what you look like.
Let me take a look at it now, brother. Oh, yeah. No, that ain't changed nothing, man. Who is on it? Smart. Let me take a look at this, brother. That's important.
What you know about motors?
So what?
The bomb squad.
What'd you say? That's broke.
Don't stop him. Shit, what the fuck you doing? I got full coverage. My car. I'm wasting somebody.
That's what you're thinking about?
Yeah, cause my homeboy got 700,000, 700 something, and then he sued the police.
Oh, you
But he's trapped. It's like a couple of court and they got papers. So they woke up with handcuffs.
I think it was too much pressure on him. When he started wearing regular jeans, he didn't like it. He was like, nah, I gotta dress up, yes, business.
Man, you don't want to play with them, man.
She said, no, Wendy's is not going.
Hey, you don't want to play with 7 trucks.
She's a girl.
He's a big boss.
But you can't even walk straight.
He doesn't walk straight.
You
But like,
can't stand up for more than 2 hours.
but he's a boss, so he don't have to look up.
He be on FaceTime all the time.
And his 10-man crew.
It's a
Yeah,
FaceTime.
man.
You got a guy to do
They don't have no
tile,
girlfriends, they don't got no jobs.
electric guy,
Yeah, he sits on his
drywall
phone.
guy.
Yeah, money is never more important than your health.
None of us, look at his face. Who's doing it?
Carry
He
the
keep
chain for his belly button.
Yeah, I do want to go to change. Nah.
You go upset.
He's like, "Hey, the lottery."
Oh, every time he plays
Yeah, they used to kill me when they used to, man.
Texting, I'm like, bro, that's not what you're doing. Younger night, come on.
People die.
He's saying if you survive, you.
But most people survive though.
Most people?
Yeah.
You sure most people are
Most
like?
people I talk to, they survive. Most people I know.
I say about 35–40% on survive. The rest of them, you know, serious. Getting hit by a semi
It's
truck.
like being like a fake gangster.
Cause all my friends, they got hit by
Yeah, he
semi
was like,
truck.
yeah, I'm just
They all
like
dead.
a gangster. I mean, not a gangster.
You be the one.
How many friends have got hit by a truck? Real.
And then like he said
You know what's fucked up though? Right? You don't die, but you get like permanent.
He might well say it like that. What the fuck?
Your ass can't move. You can't you
Well, the only thing that got messed up with that is they can have no sex. The heat messed up. You know what I'm saying? Like,
you got that fucking blowing through the top.
No,
Get around and shit. That shit ain't gonna be too. Care about tapping out if you wanna get it stimulated right.
So if I ask you the low voltage side, I was really asking for clarity. We could have been going for the stat transformer. I'm not even gonna hold you to that part, I'm gonna keep it simple. I'm gonna say low pressure, high pressure, and compressor contactor, which is a load. That's all I want you to show me. You don't have to show me anything else. I wanna know that you know the difference between contactor, coil, line voltage,
So this wouldn't be a normal open contact? I thought it was normal open, that'd be normal closed.
yeah, it could be, but what's that on the end, compressor?
Yeah, that's the first one. My compressor would go on another line.
I think you got too complex with it. I was just looking for those items, knowing that if that's 24 volts, and the 24 volts would go to, come from the thermostat, when you power it up, it would come down to the power lay. This is for like an AC. It would go through LP, low pressure, high pressure, into the coil of the contactor, which is 24 volts. Saying that the series circuit is the safety circuit that if we open on low pressure, high pressure, or flow switch, the 24 volts will open and the contactor will never close. You're doing it too complex. You don't have to do it that complex. You can do it on a straight line like that and put it on there. Because it is a series circuit. I'm not trying to make you draw a whole mechanical drawing. I'm not trying to do that. I just want to know if you know how that 24 volts looks.
I'm not getting, are you asking for, I know what the.
Series circuit is 24 volts. Just pop them devices in there.
Do I know?
You funny, man. Why you take off your glasses? Why you take off your glasses trying to hear him?
And if it goes to the compressor contactor, unless you're going from right to left, all you have to write is CC, and we know it's going to, the 24 volt side is going to.
So I wouldn't have, it's no real symbol for compressor contact?
You can write CC, that stands for compressor contactor, but you already have a symbol right there.
Okay, gotcha.
Yeah, so CC, that's the 24 volt side. Just write CC.
Just write CC over here.
Over the contact that you got normally open. You can do it that way. So I'm just trying to see if you get the basics of how it's done when 24 volts comes. We know the 24 volts came from the transformer, and from the stat when we turn it on, if it's on cooling, what wires would be energized during the cooling. Y will energize that contactor, but what else has to be energized when we turn on the compressor?
G.
For what?
For flow,
You gotta have a flow.
you need the, fan motor, right?
So what wire the thermostat represents the fan relay?
G.
What color?
Green.
See, okay, so those wires, when you put the thermostat on cooling, R, G, and Y are energized. And when the fan is gonna be energized, and the fan is gonna be energized in the indoor unit, the air handler, and that relay is gonna be energized, and it's gonna have to have a common from the transformer to the other side, and that's gonna close the relay, and the air handler fan is gonna run. At the same time, a common's coming to the outdoor contactor, and the R from the thermostat is coming to the other side of the contactor, it closes. If those pressure switches are closed, then that represents low voltage. And then I'm not asking you to make it to the upper half, because when it closes, the compressor will run and the outdoor fan will run. That's all I want you to know right now. So and what that does is tell you what circuit to troubleshoot. I have to come from the thermostat and make sure I have 24 volts from the 24 volts. The colors I asked you about would actually be in the air handler on that board. Those are the colors I was asking you about. They're gonna be right there. Those are the colors. And so those are the colors that's responding to the thermostat of what position we put on. Energizes the circuit, closes switches pertaining to air conditioning, and then the outdoor unit will run. And so that's the part, I'm trying to see how you know low voltage, and then once we know low voltage, we know that once low voltage is energized, then line voltage does the work. Because they have a shared component, which is a contactor or a relay. Anytime we have a shared component that has low voltage to open and close through a coil, when we close the switch, something's gonna run. That's all we doing. It's not running by low voltage. The switch is operating, energizing and de-energizing with low voltage, 24 volts. And that's what we need to know. So that part for you is okay. I'm not gonna do that, so I'm gonna get somebody else for something else.
So that's right now.
Mark,
what was that? What did you just draw up there?
Low voltage side to the the low voltage side to the schematic.
Okay, so
Pressure, what is it?
Anderson. Samuel?
Yeah, I'm right here.
Where?
Here. Oh, here. Cameraman.
Okay, so Samuel. If I energize this circuit and the relay closed, but the outdoor fan did not run and the indoor fan did not run, what might be my problem? Well, let's stay with the outside. I energize the circuit, the CC contactor closed, but the compressor didn't run. What could be the problem?
You said it's closed and the compressor didn't run, so what's the problem?
What might be the problem? Relay closed. When relay closed, something's supposed to run, but it's not.
There's no voltage going through?
Where would I check? There's several places, but where would I check for that voltage?
L1?
It's a 240 circuit, so you have to check what?
The contactor.
L1 and
L2.
where would I check it? Would I check it at
The
L1
contact.
and L2 tells me the contactor? You could, but if I didn't have it at L1 and L2, where would I go next?
Just the contactor, right?
We're at the contactor.
Mm.
Something feeds the contactor. It has to be 5 feet from every machine. We call it a service what?
Break.
Service disconnect.
Service disconnect.
So if I don't have it there, now what I'm gonna check?
The breaker.
There you go. Okay. See, it ain't gonna be rough. It's just gonna be. Okay. That's Samuel Namir Brown.
He not here.
No, he was here today though.
There's a mirror and
This is.
I mean, he was here today.
I know why my grades, I don't know where they went, because they got in Stephen's name, you know, I'm looking, I'm putting these grades in, cause I got them. Galvin, Castrizon, Dresden.
He just left.
He did?
He left, they fell up front.
Where was he sitting? What wires I jump out to make the heat come on? Gas heat?
Gas heat?
Mm-hmm.
Red end. Yellow is AC. Green is fan. White. So it'd be red and white.
How about airflow?
Airflow, that'd be fan. That'd be red and green.
So if I wanted heat, I would do all of them together.
Yes, R, G, and
Okay,
white.
so the gas came on, boy, that was a good job. And the fan didn't come on in the furnace. What might be the problem? Could be several problems. You could just name one.
It could be the contactor that turns the fan on.
Thermostat.
We like to think of that as a relay. Because
Relay.
a contactor can handle more amperage, over 30 amps. What about, what could be wrong?
It could be the indoor fan relay.
What would be wrong with the indoor fan relay?
The coil could be burned out.
How would you test it?
You test it by testing resistance.
So
Use resistance.
what
with
would
your
you read if
multimeter.
it was open?
Come again?
What would you read on your meter if
It would say OL.
If it was open, okay. You did pretty good, man. Andre Chaplin. Who is Andre Chaplin?
I just talked to, that was him you just talked to.
That was you?
Yes, sir.
What did I give you a grade to? Oh, I gave it to you.
Oh, we get a grade right now for this?
Oh, God. Claire Saint Jerome?
He ain't been here in a while.
Yeah? Good.
I fell, man.
So I'm gonna mark it that way. That way I'll know. Okay, Mr. Patrick Hines.
He's not here.
He's sick.
He quit.
He's sick. His car. Yeah, he's
Car
sick.
down and sick.
He sits up front for the last ball.
Car down and sick?
Yeah.
We need
That's
to
the last one.
What school, Mr.
Conyers.
Does he live in
He lives in
Goldsville?
Conyers.
That's Michael.
Ooh.
Michael lives a little bit.
Ooh. It's hard to get out of Conyers.
I come out
Yeah.
there every day.
I live.
You?
Yeah, me too. I live in
Your
Conyers.
classmate. What?
tell you,
That's not too bad, about an
Boy,
hour.
after kindness.
I would be in Father's Place.
How about, Jackson?
I'm right here.
Okay.
Today is the 13th.
You got it, bro, you got it.
So, Mr. Jackson. How much do you know about a gas furnace?
The gas furnace. I know it got flames. Gas valves. I know a couple of components into it, but I don't know
Okay, so
the whole operation of it.
what is a flame sensor?
It senses when the flame come on.
And if the flame doesn't come on, what happens?
I think it'll start blinking, like the LED light will start blinking, it'll tell you something wrong with it.
What is it gonna tell me? Why is it blinking?
If the flame don't come on, something wrong with the gas.
What would be wrong with the gas? Making you think and talk. What, something wrong with the gas? What? You asked for $97, man. What's wrong with the gas? Why I give you $97? What's wrong with the gas? What's the quick, simple answer?
It's not working, but I mean, maybe it's not getting a charge.
It's not connected.
You was doing all right for a minute.
It's not
Gas
connected.
not working could be your gas is off.
Oh,
Nothing's wrong with your furnace. We'll run into that. Your gas is off, and how will you know it's off if you go outside? Maybe you ain't had yours off. What did it look like?
Got the tag on it.
What is on it?
Yeah, tag on it.
It has a brass nut and it's locked off.
Because you ain't paid the bill.
I don't cut him off.
So how would I jump out the gas to make it come on?
well, I mean, if it's out.
No, this
hey,
time,
hey,
you go on to another service call, you told them to call you back when your gas get turned on. Now you're on another service call, you go there, and you hear the gas valve click, the gas comes on, but it won't stay on. What's wrong? It goes on and off, what happens?
Oh, dang. We did just talk about it.
That's what I asked.
What would you need to make the gas come through? What's before that? What's the operation?
Oh, don't you change the sensor? Don't you change the sensor?
Let him answer the question.
It go on and off, it's not coming on no more.
That's how it does it too, to come on,
The sensor broke.
then it'll go
messed
off.
up.
That's
You
not
got-
your question. If you ask another person's question, I'll take 10 points off of you.
Oh, okay, we just helped
Cause
him.
he has to, you can't help him, this is a quiz. He has to learn this, he has to learn this, and he will learn it. He'll learn it. He doing all right, but you know off and on is, all we always talk about, off and on involves what? Some kind of what?
Switch.
Switch or control. So what control were we talking about this morning?
The limit switch.
Let me think about that. How long did it stay on?
I mean, not
5
too
minutes?
long.
How long did your furnace stay on before it went off? You tell me, I'm just saying, this is a scenario. It could be right if you get the right answer.
I don't understand the question. You saying how long? Did you ask
Fire
furnace
came, I
or
really
the
gave you,
broken furnace?
I gave you, a question of gas comes on, fire starts, and it goes off. And it comes on and go off, so that's not 5 minutes, but I let you slide because you said limit. And I said, well, if he can tell me something about a limit, I might give him credit for it.
You asking me what?
I'm asking you why won't it stay on? Why won't the fire stay on?
Limit
You want
broke.
me to give you $187 $27, you can't tell me why, I wanna know why.
I mean, the limit switch broke, right?
The limit switch,
There.
it's another component that should have been there. What did the guy use money to clean off in the video?
The sensor,
And what's the flame sensor's job?
sense when the flame come up.
Okay, cause it's a safety. Just like these are safeties, it's a safety in the sequence of operation of gas heat. If I don't sense fire, gas shuts off. That's why it's on off.
Oh.
Alright?
I go to work with her.
Yeah, you can. You go to the bookstore too, when you get out of work, you read that book. Okay. James Jonathan.
Right here.
Hey.
Mr. Harrison, some of us gotta go to work and
Yeah.
stuff, like, I'm just saying.
I gotta work, I gotta pick my son up. at
Yeah,
2:00.
like,
He's
I'm already in work.
Huh?
I'm already in work.
Yeah.
I ain't gotta pick up no kids. They got cars, and if it break, they better fix it, cause I ain't fixing it.
That's right.
I got
Alright,
We got saved.
Everybody bed.
It's
It's alright, something say about a bed.
Oh, I need my question in there.
bring this back next week.
next week.
come on.
Next week.
You done made me sit here. I'm going.
Alright, bro.
Give me my
One more
question.
question.
Give me my question. I need my question.
I knew I was about to answer that shit wrong in here.
We're gonna do 17 and this next class,
17 and this.
and this. We're gonna
We haven't
start,
learned anything about this.
that's why we're gonna do 17 first.
17 and what?
17.
And the paper that he
Oh,
gave
okay.
us today.
17 is gonna be the review totally, just 17, and then we're gonna do this